This video is going to quickly go over partial fraction expansion. So, partial fraction expansion is a method to split up a frequency domain equation into pieces, making it easier to get the inverse Laplace transform. I'm going to go through just a couple quick cases for this. So, case number one is where we have distinct roots. So, if we have x of s, which is n of s, our numerator, over our denominator, d of s, we can say whatever that numerator is, it doesn't really matter. Our denominator is going to have a bunch of different roots, s plus r1, s plus r2, all the way through to s plus rn. That's how we can factor this out. Well, we can say that this system is equal to some constant c1 over s plus r1 plus some constant c2 over s plus r2, and keep going until we get to rn, where n is our final root that we have. And then we could actually solve. There's a direct formula for solving for this. C of I is equal to our limit as s approaches our root, negative r of I, of x of s, our original equation, times s plus r of I. So when it's x of s here, it's really referring to this equation right here. That's how we can solve for all these CIs and end up with a simpler equation. Now for case number two, where we would have repeated roots, we can't do exactly the same thing. So again, let's say that we have some numerator and some denominator, but at the end of this denominator, we have multiple of the same root, or to a power essentially. So we have Rn, which is repeated p times in this case. So we can still break this up in the same way as before. For R1 to Rn minus 1, it would be exactly the same as before. And then for this guy right here, the repeated root, all we do is we start with p on the bottom for Cn, and then as we increase Cn, we're going to take p minus 1, p minus 2, etc., until we get to a power of 1 at the end here. And then C1 through Cn minus 1 are found the same way as always, but Cn and onward are found by taking the limit with respect to that root of x of s times s plus rn to the p, or the derivative with respect to s for x of s times s plus rn to the p, etc. So first order derivative, second order derivative until you get to the end here. And that is the basics for partial fraction expansion.